Greetings, this is M squared, and we are going to solve some more absolute value equations. Let's go over our rules again. Our first step is to get the absolute value expression alone. Might not just be an x in there. There can be other numbers in there, but we want to get that expression alone. Once we do that, we check for negatives on the right side because an absolute value cannot equal a negative number. So if that happened, we would know there was a no solution. We're going to write two equations, one with the positive value of the right side, one with the negative. We're going to solve and we're going to check. Well, let's get started. Right here, we want to get the absolute value expression alone, so we have to add 15 to both sides. When we do that, we get the absolute value of 2x plus 3 equals 15. So our two equations are 2x plus 3 equals 15, or 2x plus 3 equals negative 15. One with the positive value, one with the negative value, because if something is 15 away from 0, there's only two ways that can happen. This would have to equal 15 or negative 15. So now we solve. We get 2x equals 12 or 2x equals negative 18. And when we divide both sides by 2, we get x equals 6 or x equals negative 9. So those are our solutions, and now we check. We'll just check verbally. You could do this on your calculator or on a computer, on paper. 6 times 2, if we put 6 in for x, is 12, plus 3 is 15. The absolute value of 15 is 15, and 15 minus 15 is 0. So that checks. X equals negative 9, we put that in for x. 2 times negative 9 is negative 18. If we add 3 to negative 18, we get negative 15. The absolute value of negative 15 is 15, and when we subtract 15, we get 0. So those checked. We know we're right. Moving on to the next one. This is a plus 7 out here. Even though there's a minus sign, some kids get confused and they think that minus sign goes with the 7. But if it's after the 7, that goes with this expression. So we minus 7 from both sides. That cancels out, and we get a negative 4. And then another mistake kids sometimes make is they forget to drop this negative down. That's in front of the absolute value, which makes a big difference, because if you didn't drop that down, then we always check this next, and it's negative, so you might think there's not a solution. But there is a solution to this one. So make sure you are dropping down negatives that are in front of absolute value signs. To get rid of that, because we need to get rid of it to get it alone, we multiply both sides by negative 1. And when that happens, the signs just change. So we get that and that. That's what happens. They go to positive. I'll leave it there though so you can see what I did. So now we're ready for our two equations. So we have x minus 1 equals 4 or x minus 1 equals negative 4. When we add 1 to both sides, we get x equals 5. When we add 1 to both sides on this one, we get x equals negative 3. So now we can check. When we check, we plug the number back in for x into the original and see if it works. So 5 into here would be 5 minus 1, which is 4. The absolute value of 4 is 4. 7 minus 4 is 3. So that one checks. Let's put a negative 3 in for x. Negative 3 minus 1 is negative 4. The absolute value of negative 4 is 4, and 7 minus 4 is 3. So check, check. We know those are right. Alrighty, this one looks a little different, and you see there's an x over here. Now I don't know if you remember what an absolute value equation looks like if you graph it, but it's a V shape. And a lot of times we get two solutions. Remember, so when you're solving, you're finding the x-intercept. So if you were to graph this equation, if this was a y, you would to graph this, you'd get two solutions, or two x-intercepts, one at 6 and one at negative 9. So that happens a lot. You could get one solution if this little point where it changes directions was on the x-axis, you might get one solution. And if it was clear above the x-axis, you might get 0 solutions. That's how you get that negative on the right side, would be a no solution. But when another x outside of the x that's in the absolute value pops up, it changes the picture. It's no longer a V. So you might not get two solutions here. And I'll show you the picture of the graph in a minute. But keep that in mind. You should recognize things like that. So we have to get our absolute value alone. We still solve it the same way. So we minus 4 from both sides. We get the absolute value of 4x minus 5 equals 7x plus 4. So when it's alone, we're ready to make our two equations. Also, I might add that when there's x's, it's hard to tell whether something's negative or not. So we just usually always make two equations, even if this first expression was negative, and then check the solutions. Checking's your best way on these when we're not really sure what's going to happen. Okay, so we set it equal to this, and then our second one we set it equal to the opposite of that. So we add, let's see, I want to move my 4's on that side, and I mean my x's, my 4x, and let's move our, let's see, what's 7 minus 4? It's 3x. And negative 5 minus 4 is negative 9. So when I divide, I get by 3, I get x equals negative 3. That's one of our answers. Over here, I'm going to move the 7x on this side. And I'll move the 5 over there. That cancels, and I get 11x equals 1. And when I divide, I get x equals 1/11. Now I want to check. So I check my negative 3. When I put a negative 3 in there, I get 4 times negative 3, which is negative 12, minus 5, which is negative 17. So the absolute value of negative 17 is 17, and when I add 4 to it, I get 21. So on the left side, I got a 21. And when I put a negative 3 in here, I get a negative 21 plus 8. Well, these are not going to be equal. So we can tell right now that this is not a solution to our equation. And of course, that means we did everything right. I know that I did this right because I've done this before, but you might not. So you might want to go back and just make sure, or grab your graphing calculator, which I'll show you in a minute, to graph it to make sure you're correct. Now let's check this one, 1/11. It's easier when you have 1/11 probably to use a calculator. So let's get this where you can see it. And let me move this a little. So I'm going to put 1/11 in there. So I'm going to say 4 times 1/11 minus 5. Now that is, I'm going to times it by negative 1 just to get rid of the negative, because then we need to add it to 4. And the reason I did that, because when I take the absolute value, it goes to positive. So now I'm going to add 4 to it, and I get 8 7/11. So now I'm going to check this side. So again, I'm going to put 1/11 in. So 7 times 1/11 plus 8. And I got 8 7/11. So this one worked. So this is our only solution. Now let me show you the picture of it on this calculator. You'll see it's not a V. You'll see one line comes up, and this scale is like 200 and 100, so it's pretty zoomed out. You'll see that it just barely crosses the x-intercept just once, the x-axis just once, and it's right there. So I always like to double check in case I'm, did something wrong. I can go and figure that out. So when you get x's over there, it does get a little more challenging, and you might not get the 2 answers. So that's why it's really important to check your solutions. Check, check, check. I hope you check. M squared signing out.